Whoa. Okay, we're gonna get going here in a moment. All right. How was everyone's weekend? How did the mock test turn out after working on it a little while? Yeah. That one's always a little bit weird, you know. It can be stressful sitting in that room and getting started on it, but once you give it some time, I think the questions come through. I know you guys over the weekend had a bit of a chance to do some readings on kind of HTTP and requests and stuff. So that's going to be the focus of today's lecture. We're going to dive into it, see a few examples, and also look at kind of how the internet works. So last week we were just doing kind of JavaScript fundamentals. We learned how to write programs with satisfied specific requirements, and we ran them within the Node environment. This week, we're kind of going to be starting to add the web into web development. HTTP is the main way that we'll be communicating across the internet, across the web, and it kind of adds the communication and a lot of the functionality to our web applications. Specifically, we're going to be looking at protocols, network layers, and HTTP requests. Maybe before we jump right into it, let's just kind of get a baseline for what our current understanding of a couple of these things is. So the first one we said was protocols. Starting now, what's our kind of understanding of protocols? What have we heard about them? What are our thoughts on them? How server and client communicate. Cool. What else? It can be HTTP or HTTPS are example of some protocols. Anything else that kind of jumps to the mind? Designated by port number. Nice. So we do have some things that we're familiar with, whether from the readings or beforehand. That's cool. We also had network layers. We'll go into that. Maybe we don't need to think about it, but if we want to break down this HTTP or HTTPS, what does that mean? What is involved in an HTTP, or what is it? Hypertext transfer protocol. Whatever that means. What else? Go for it. What are you thinking?
Is it the actual brass tacks of it? Is it that it converts everything to? No.
Yeah, no worries. It's good. So maybe this one's a little bit more of an unknown than protocols. Cool. Well, that's what we're kind of here today to figure out. So yeah, to start with, we're going to look at an overview of how the internet works. So we've all had many hours with the internet. We know you type in a URL into your browser, you hit enter, and like bam, you see a web page load. We don't need an example of this, but just for fun. Let's see, another site. Oh, this one's like seizure inducing, so I'm not going to do that one. Yeah, a little bit. Seizure websites generator. All right, let's go one more. Oh, cool. So these are kind of useless sites, but we can see that the general process is, we click on a link or we type something into a URL. There's a brief second of a pause, and then we get some content. But how does all of that happen? And that's what we're going to be kind of looking into, and that's what we're going to be learning how to do. Whoa, how did this get so big? There we go. So we type things into a URL, and our URL is broken down into a couple of different things. At the very start, if I'm on this page, we can see I have this HTTPS. I could also have HTTP. That's known as the protocol. HTTPS and HTTP will be the most standard ones we've seen for getting websites. Then we have that followed by the domain. So example.com, whatever site we're building. And then we have the path. The path navigates to the specific page of our website. And then we have some optional things like a query string and fragment. Query strings are specific for kind of letting the website know how we want to filter what they're showing, giving them some extra information. So the example here, we have a query string, and we have the name equals article, and topic equals SEO. So maybe the page they're viewing has an article called article, and the topic is SEO, or the type is over to article, and topic is SEO. It provides some additional information. In order for your browser or your client, so from now on, we'll be looking at clients are the users of our application. They're the people who are using their computers, their machines to view our content. So the client, where the front end code lives, it needs to communicate with the server. A server being another machine that's networked somewhere out there on the internet, on the network. Your computer sends a request for the resources that it needs from the server in the form of a URL, and the server in turn responds with the requested data. So when we were hitting that like funny link thing, a request is going out over the network to some server located somewhere, and that's saying, okay, you want all these like images, you want this like maybe HTML and JavaScript, and it's sending us back that. Most commonly, we see resources as web pages, but you can request other resources over HTTP. For example, here, if we look at my URL, I'm requesting a JPEG. I'm requesting an image. So this website page or this HTTP request is a static image. Did it again? So this is achieved communication over a channel called HTTP, or Hypertext Transfer Protocol, like we mentioned earlier. HTTP is the background of the web, and it's the primary way that people are going to be communicating over it. If the internet is like the information highway, HTTP makes up some of the rules of the road. And this idea that the internet or this interconnected network is kind of like a highway is a good metaphor that we're going to be using looking forward, because it lends itself to a lot of the ways that things are sent and communicated on the network. So this hypertext transfer protocol is just technical lingo for helping devices communicate over a network by a series of requests and responses. So HTTP, we're just saying like, hey, can I get that? And someone else is saying like, yeah, here it is. Or maybe, no, I don't have that. So protocol, what exactly is a protocol then? It's kind of like more generally an official procedure or system of rules governing affairs of state or diplomatic occasions. Like this is the dictionary definition of the word. Protocol, for example, forbids the prince from making any public statement in his defense. So outside of web development, protocols are actually everywhere. We probably run into like a couple dozen of them each day. An example of an informal protocol could be like a phone call. You know, I call someone and it rings, and when they pick up, I expect them to say like some sort of greeting, like hello, and then I in turn respond like, hey, it's Travis, or a response to. And then when we finish the call, there's some additional exchange of greetings. They're going to say, you know, sorry, I got to go. I'm going to say, you know, nice talking to you. See you later. If any of those set of kind of expected behaviors are missed, you get like a really awkward and like horrible phone call. If I'm calling someone and they pick up and they're just like quiet and they don't say anything, that's weird. And then, you know, if you finish your phone call and someone just hangs up, super rude. Like in general, protocols, in order for the communication and interaction to go smoothly, both parties need to be like aware of them. Maybe we can think, what are some other examples of like informal protocols that we might encounter just like in our day-to-day lives? Yeah, that's a good one. So standing on the right side of the escalator, walking on the left. Those people who stand on the left side, super annoying. Any other ones you can think of? Streetlights? Yeah, maybe a more crucial protocol than the other ones. If you're ignoring like streetlights, you know, all chaos and accidents break out. And that's a good one because it kind of links back to our road example of the network, and we'll see how that one might even help with our analogy. So yeah, for all of these, each involved party must know the rules in order to communicate effectively. If you're like an alien just dropped into Earth and you try and drive on our streets, you're gonna have a bad time, unless I guess someone's telling you the protocol beforehand. In the context of networks like the internet, protocols are the rules that determine how to send, format, and receive data between network devices. These could be servers, routers, phones, personal computers, maybe like a printer, like a smart refrigerator. Anything that's connected to the network can maybe communicate over these protocols. With the internet's kind of like Shrek or an ogre, and ogres are like onions, and onions have layers. So the internet and networks are like very complicated, and to kind of break them down and make them easier to build, easier to run smoothly, they're broken into layers, with each layer serving a different function. In general, the bottommost layers cover the most basic of things. So the physical layer, bottom one here, it says it transmits raw bit stream over the physical medium. So that means in the network, our actual data has to be transported like physically somehow. In most cases, we have like copper wire, and our data is streaming over, you know, electric pulses. That's what the layer one is concerned with, like zeros and ones. Or Wi-Fi, it's sent over not a physical medium, but like the signal medium. And again, the physical layer would be concerned with how that works. But it'd be really annoying if, when we're coding our web applications, we have to think about like, oh, how am I going to group my like zeros and ones? Like, how am I going to send that to someone? So the layers above build on the layers below. So this like data link layer doesn't have to think about zeros and ones. And as we move up, we get less nitty gritty and we get more abstract. In general, you're not going to have to remember like, oh, what is the network layer? What is the transport layer? It's just a good idea to know that the layers are built up one on top of each other using the layers below. The one that we're going to be focusing on is this like 7th layer here, this application layer. So it says this is the human-computer interaction layer, where applications can access the network services. That's a little like unclear, but we're going to explore it a bit more. So we kind of looked at this one. Just before we go on, the application layer, this topmost layer, is where a lot of the protocols that we're going to be looking at live in. So HTTP, HTTPS, this is a element of the application layer. This one might be a bit harder to answer, but have we heard of any like network protocols that are jumping to our mind, maybe that aren't like HTTP and HTTPS? Yeah. Sorry about that. But are there any other like network protocols that jump to our mind besides HTTP and HTTPS? Mail 2, okay, cool. FTP, yeah, file transfer protocol. PTP, peer-to-peer. Oh, which one? UTP, okay, cool. Nice, we actually know quite a bit. Any other ones? TCP and UDP, yeah. So the last two, TCP and UDP, are actually protocols of like a bit of the lower transportation layer. For the most part, we're going to be thinking about these ones, but there are protocols that make up different parts of each layer. So here are some other ones. We have FTP that we mentioned. We have POP3, which is Post Office Protocol, IMAP, SMTP, BitTorrent, which I'm sure none of us have used in any suspicious ways, DHCP, and DNS. These ones kind of here are a bit interesting. They're not like used so much, but early in the days of the internet, you had kind of before Gmail, you would do something where locally you would have a like a mail client, and this was like Outlook Express, or no, just Outlook was kind of like an example, and that would have to communicate with a mail server. So this is like your mail server, and then your mail server would communicate with like this other mail servers who had their own like mail clients. So your local computer would like check this server to see like, do I have any mail that's like not that I don't have locally, and it would fetch it. And then if it wanted to send mail, it would communicate to the server, and then the server would send it to like another mail server who would like forward it down to the client. So you had like two things in working together: your local like mail client and your mail server. And these could be like different. Like this could be Outlook. This could be like I forget the ones, like AOL Mail or something. Nowadays, like with Gmail, your client and server all like kind of work together. Like Gmail is just a combination of the two sitting back here, and you don't really have something locally. You just have like your browser that fetches the page, and Gmail will do kind of both of those things. But I think POP3, I think both of these were from like the mail client to the mail server, and then this was from mail server to mail server. One of the two. Either way, in most likely scenario, you won't be seeing or using either of those. And then the other ones that we looked at, some of these have to do with like transferring data through peer-to-peer networks like BitTorrent and Well, FTP is like if I have a file on my computer and you just want to download it, you can set up a FTP link with me and just say get a photo that I have. But the main one, again, we're going to be focusing on is HTTP, Hypertext Transfer Protocol. And it sits in the highest network layer, the application layer. The application layer is responsible for process-to-process communication over the network. So process-to-process is like program-to-program. I have a program running on my computer. There's a program running on a server computer. And HTTP is those two programs or processes communicating with each other. HTTP, like when it was first created, it was designed for one machine to share documents and any number of clients to get those documents from the machine. So you can make a request, hey, I want this file, and then with HTTP, the server then responds with the document or with some sort of response. Again, like HTTP is made up of these two like main pairs of things, this request and the response. The server sits at home waiting for someone to knock on their door, and the client can anytime walk up, like knock on the door and ask for something. So we have like the server, he's chilling, waiting for someone to come and like ask for some document. And then the client comes up, can ask for like a cup of sugar, flour, and they need a way to ask for that. So they can't just come up and like gesture and grunt like a caveman. They might say, may I please have a cup of sugar? And some ways of asking could be better than others. Saying, may I please have a cup of sugar is better than just saying like, give me that sugar. The server then like goes, into his thing in the kitchen. He grabs the cup of sugar, and he like, comes back with his response. They can come back with the actual thing that was asked for, or they could also come back and say, I couldn't find that. It like didn't exist, or I didn't know where it was. So this is what happens when you type a URL into your browser. There's that initial request, the server looks for it, and then responds with the thing that you asked for. Some examples, when you just type something into your URL, you get a HTTP request and response cycle. But there's also other ways of doing these HTTP requests. We'll be writing our own HTTP requests in our applications this week. But you can also test it with, there is some software called Postman that you can use. Or in your command line, there's a command called curl that you can use. So if I go in here and I write curl to example .com, this is going to send a HTTP request, and right in my command line here we see my response. I have this whole thing that looks like some HTML. So that's the same thing our browser is doing when I go to, say, the same site. But our browser is a little smarter. It knows how to interpret HTML. It's specifically designed to display web pages. So it displays it in a human readable, or I guess more, not necessarily human readable, but a graphical user interface way, as opposed to my command line that just gives me the raw information that is sent back. Postman's another way of doing this, and it's a little more flexible. You can specify the HTTP type, or your method. We'll look at that in a second, but then I can do a similar thing, example.com, and I can send it, and I get the response here. As you're building out applications, this might be a useful tool for testing some of the request and response that you're trying out. It lets you save them as well, so if you want to, I have maybe one saved here that I can just go back and reuse again. I don't have to think and form it every time. We've seen these HTTP requests give us back websites, but they can also give us back we also saw images, but they can give us back data as well. So here's an example of a URL. This is a specific type of URL or specific type of endpoint called an API. And its purpose is to allow me to request data. So this one's a Star Wars API. And if I take this URL and I go in Postman, so I'm going to get requests to that URL, the path being API/films, and I hit send. My response back is not HTML, but it looks like a JavaScript object. And it has all of these key value pairs of information around the different Star Wars movies. So we have the title here, A New Hope, the episode ID. It even has the opening crawl, has a link to all the other characters, which are API requests themselves, so you can get data from them. And a lot of other good stuff. So we've seen that HTTP, we can get websites, we can get images, we can get JavaScript-looking objects. We see here that's called JSON. JSON's JavaScript object notation. It's a way for the HTTP request to communicate a JavaScript object, but as the request is sent and received, it doesn't know itself. It's not written in JavaScript. The HTTP request doesn't have a concept of, this is a type of a JavaScript variable of object type and has all these things. So JSON is a way to just encode a JavaScript object in pure text. So this is just the actual text, the actual characters, open bracket, with these quotes and then values beside. And then when we get it on our program side, we can turn that text that looks like a JavaScript object right into an actual JavaScript object when we're coding that way. And we'll see that in a bit. So we've already kind of seen this. The request, what it actually looks like, it's a pair of kind of key value looking name and value type of things. So if we do that curl request in our terminal, and I give it the -v flag, it'll show me the actual request that is sent. So right here, this is the information that is being relayed to example.com. We see get, we see this HTTP/1.1. We see that the host is example.com. It has something about a user agent, and then it has this accept thing. So the first line of the request represents a message, or the first line of the request message is called the request line, this one here. This is kind of the most important part of your request. It specifies the request method, so in this case, get. And this part specifies the HTTP version, which is less important. We don't really need to worry about setting this or looking at it for the most part. The second part here, we have where we're asking to get the data from. And the last part here, this user agent, is just letting the person we're requesting from, or the server we're requesting from, know where we're requesting from. So we're requesting from curl. If we were requesting from a browser, it might say Internet Explorer or Firefox or Chrome. After the request line, we have the headers. These are key value pairs. There are a lot of different headers. In the current example, you can see that the user agent, so here, is one header. And when you're done adding headers, you get this //n, which just means a new line and a space. So here, this break in the response is this, just to say that the request and all the headers are finished. The last part, a GET request has no body, therefore this is the end of the request message. So we're most familiar with GET requests at this point because we use them all the time. Post and put requests, there's other methods we'll look at in a sec, but you can actually send more information than what's in the URL with those requests. So when I'm in the browser and I hit enter here, this is all the information that I'm passing into my request. If I wanted to say send an image or send a JSON object, I can't just like type a bunch of like stuff in here, all the encoded image in. That would be like way too ridiculous. So there are ways of sending additional data besides what's in here with your HTTP requests, and we'll look at that in a sec. But with the GET request, this is it. It's only these couple of lines, the method, the path, and then some header key value pairs. Today, we just want to look at the most common request methods, and those are GET, POST, PUT, and DELETE. There are more than these, but in your average application, in your web development careers, you're not going to be using methods outside of these four. The other ones are very edge case scenarios, and these ones will cover like kind of everything that you'll need to do. So the first one, GET, that's the one we've been using. You use if you want to retrieve data from the server. You're just getting something. It's like very syntactic in its naming. You use POST if you want to add data to the server. So POST, if I'm adding stuff to the server, I can send extra stuff beyond what I have here. If you've ever signed up for, any service on the internet and you're typing in your email, your password, and all of those things, that's going to be most likely a POST or a PUT request. And along with the information, or along with the URL, it's going to be sending all that information as a POST request in the body. So it'll have your email, your password, any of the information you filled out in that form. You use a PUT if you want to edit data on the server. POST and PUT can be very similar. POST is like, I want to put this new user on the server. PUT is like, I want to change this user's username from T-Borsa to, I don't know, Travis the guy. And then the last one, delete, is if you want to remove something from the server. So POST and PUT have bodies. They have the extra information that we can pass along with the request. GET and DELETE do not have any bodies. And it kind of makes sense why, because with GET, we're just saying we want this information. We're not giving them anything, so we don't need to send anything in a body. DELETE, we're saying we just want to remove that thing. So we don't need to give them anything because they're just going to be destroying it. A GET is always a safe operation. So this idea of safe is the idea that is anything changed in the server. When we do a GET request and the server sends us a bunch of information, nothing has changed on the server side. It still has the same set of information. Its state or its current data stays the same. Whereas a POST, a PUT, and DELETE are not safe methods because they alter the data on the server. They alter the server's state. So a POST typically will result in new data being added to the server or database. So it's different. Once we've done a POST, the server looks different. It's not safe. A PUT is also unsafe. If there's an existing user and we're changing their username, the state of the server is different before and after our method. And then finally, DELETE, obviously similar. We're removing something from the server. The word safe and unsafe doesn't mean you should use and you shouldn't use. It's just referring to, you're affecting a result in the server or you're not changing something in the server. Any questions so far on these methods or the request response kind of cycle we've been looking at? So we looked earlier at this. The path identifies the resource that you want to take action on. The original intent of HTTP was just to share documents. Today we use it to build web applications. But when learning about this, like consider initially it was just like a lot of academics had things on their computer and they wanted to share those with other people. They said, hey, I have a Word file. I want you to be able to get it. And that's kind of how this was originally thought of. So this idea of like getting something, posting something, putting something, deleting something was all created with that in mind. So the path here, this is the file or the kind of thing that we want to take action on. So when you go to sitechecker.pro/knowledge base, if I'm doing a get, I'm getting something from some thing in the backend that they have called knowledge base. If I'm doing a put to knowledge base, I'm adding something to, or I'm editing something to this like knowledge base resource in the backend. A resource just being some grouping of data, something that the server is allowing me to interact with. I mentioned this, like for our case, we don't need to think about protocol version. If it says like 1.1 or 2.0, I think is the next one that you'd see most commonly, like it doesn't matter to us. It's still doing the same thing behind the scenes. Headers, we mentioned those, so that was in our curl example, like user agent is one header. There could be another like 20 in here between user agent and the end of the line. Headers are optional. Some, like user agent, are very important, but there's like a bunch of them that can be done. You don't need to memorize them all. There's like tons of them. And in fact, you don't need to use a predefined header. Like you can make your own header. Like I could call mine like Travis's stuff and set it as a header. But there's a lot that are commonly used. This is just like a list of some of them. As you can see, there's like so many. And they all would be used in a pretty specific case. So you're not memorizing these, you're just looking them up when you have to. The last part, the content body is used for sending data to the server. Can be used to upload files or update a database. Post and put are the only requests that have one. Now we're going to look at the server's response. So it's very similar to the request. If we look here, we see this was our request, and here's our response. So server response contains three parts: the status line, headers, and then the body data. So the first line is the status line, and this number is the part that we're thinking of. So your HTTP status is letting you know what the result of your request was. So 200 is like a success. Like we found the thing most likely, and we're like giving it back to you. There's a bunch of other numbers, like 404 you've probably seen on sites. That means like that wasn't found. That all communicate something that the server wants to let you know. The version you can skip. So this again is not as important. And then these are all the headers that the server is sending back to you. So we have one called cache control, one called content type, the date. All of these things we're not going to be too focused on. But again, if we see one that catches our eye or we end up having to interpret one, we can just look them up on a need-to-know basis. So this is like the common example. If the server doesn't have a document to serve, it would respond with like 404 not found. These are some of the common status codes. We have 200 is OK, 301 moved permanently, 302 found, 400 bad request. There's a funny site we can go to. If you go to, what is it? So if you go to HTTP cats and you type in a status number. So what's a status number we could type in here? So if we go 404, it shows us like a cat representative of what that, and like information on what that status code means. Or if I go 500, internal server error. If I go 403, forbidden. So you'll get comfortable with the status codes as you use them more. I mean, you can always look them up as well. So don't think that you need to go and like memorize them all right now. But the most common ones will be repeated a lot, so you'll get a pretty good idea of them. So again, these are some of the headers that we saw. You can extract useful data or useful information from them. This one in particular, you can we know that this request, we got this back, which is of type text or HTML. When we did this Postman one, this wasn't HTML or text. It was it looks like JavaScript object. So if I go to the headers, I can see the content type is application/JSON. So that header is pretty useful. It will let you know what type of information you're getting back. The last one we can see is like 1,270 bytes. The content body, so this is kind of the whole reason for our request in the first place. It's the resource that we asked for. It can be a document made up of HTML, it can be JSON, JavaScript, CSS, it can be images, it can be all sorts of things. So here, our body was this big JSON thing, and here our body was the HTML as text that we were passed from here downwards. Typically, the client software makes the request, but you can also use other tools for testing. Curl we looked at, Postman. These last two are other things that you might find helpful. You can look into the documentation. I'll include them in the notes. And now we're going to take a break. But again, if there's any questions during the break, bank them and then let me know when we come back, and I'll try and answer them. We'll do 15 minutes, come back at like 2 to 10. Do you get any good food? So we're gonna try and build an application kind of using some of the things that we've been learning about. So our goal is to build a Node application that can make an HTTP request to a Pokemon API and return, like, who's that Pokemon? So if we look at, yeah, all of my lectures are just Pokemon. So this is a Poke API, similar to that Star Wars API we can look at. So APIs, there's tons of them. A lot of bigger companies will have APIs, like Amazon API or Spotify API or different things. And what their main purpose is to offer a set of data to you that you can use and interact with in your applications. So this one may be a little bit more silly, but the purpose is that we can use this API to get a bunch of information on Pokemon. So this is our documentation here. It says, if we follow this URL and we give it Pokemon / a Pokemon's name, it's going to return this stuff. We can also go Pokemon / a number. So if I click on this, it gives us the return. If I go in Postman, and I think I had one saved here, yeah. So we go a GET request to Pokemon or Poke API / API / v2. So that's just the API and the versioning. And then this is the resource that we're requesting, Pokemon, and we're giving it a specific one. So there's like crazy number of Pokemon right now. So someone throw out a number from like 1 to probably like 1,000. 267. So we get this JSON thing back. We see that the name is Rivalry. Oh wait, is this, that's the ability. Okay, let's see, where's the name? That's, holy. I know it's in here. I thought it was at the end. So the suggestion was, let's look at here. Well, if we, it's just going to be a similar. Oh, yeah, that's smart. Okay. Forms. Now this is, I think there's another spot that it's going to be. Species. Species. Okay. Okay, yeah, we'll look up species then. Beautifly. Wow, what was it? 267. Wow. So we're going to try and use this API to kind of get our program to be able to return, what the Pokemon's name is when we type in that number. Specifically, we're going to be using this endpoint, so Pokemon / and then we'll give a number in right here. So to start off, I'm in just a folder called code right now in the notes, and I'm just going to make a new I would want to try to make a new file. I'm not sure. Sometimes when I resize this, it breaks on me for some reason. There we go. So I'm going to make a new file, and I'll call it who's that Pokemon.js. So we'll go into our text editor. I'm going to get rid of this for now. Go into code, and I have our new file. So the idea was that we wanted to make a function. We'll call it the same as our file name. And we want to give this function a number. And we're also going to use a callback. And then the idea is, given a valid Pokemon number, return that Pokemon's name. So in order to do this, we're going to need to do an HTTP request to the Pokemon API. With our Node applications, we remember from Friday that we can require packages to use, and we're going to need one called HTTPS to make HTTP requests. And this package is kind of built into Node, so I don't have to download it. I can just do require HTTPS, and I will have access to it. And the syntax for using this package is I can use HTTPS, which is now the whole package that I've imported, dot, and I can specify an HTTP method. So in this case, I want to get stuff. So I'm going to use the get method, and then I'm going to pass it a path, and then a function, a callback function, that will be called when this request finishes. So I'm going to say response, and then in here we can console log the response. So can anyone think of why, with this HTTP request, do I need to get my response in a callback? Yeah, it's because this request is asynchronous. My application can't get this information instantly. It sends the request off to some server, so it has to wait for that to come back. And anytime JavaScript is having to wait for information, it can't get it instantly. It's going to try and do that asynchronously. And with an asynchronous function, if I say they tried to do this in a different way, if I just went var response equals this, I'm trying to save to response right away the result of this. And so this asynchronous function gets started, and nothing gets saved to response because it doesn't have it yet, and then it continues down here. Continues. Instead, when I do this kind of structure, I'm saying start this HTTP request to this path, and when you're done, I'll let you determine when you can call this callback and give me the response. And so the path in our case we wanted to use was this one. So we want to do a GET request to Pokemon API.co/API v2 Pokemon and then our number here. We don't want to just look up Beautify. We want to look up a customizable one, a dynamic number. So I'm going to concatenate the passed in number to our function onto the end. So if I call this function with a 3, it'll call the path, all of this, /3. And to test actually instead of console logging our response, we're going to return it because our wrapper function, who's that Pokemon, wants us to, not return it, we want to use the callback on the response. So then to call this function, we're going to go, who's that Pokemon? We're going to give it some random number, and then we're going to give it a callback function ourselves, getting the response. And in this function, we're going to console log that response. Okay, so our flow so far. We call this function. We give it a number, and we give it this callback to run when who's that Pokemon wants to do it. It calls an HTTP request to this API, and when that gets completed, it runs this function and passes the response onto our callback. So at this line here, at line 8, callback is this function. So we're calling this function with response. It's getting sent from here to here to here, and then finally to our console log. So if I save this, and we go node, who's that Pokemon, we'll get an error. Let's see. We forgot an S, I think. Oh, nope. Oh, yes, you're right. So we're trying to do HTTPS request, and we put HTTP here, so we need to make that an HTTPS request. Okay, so now we get this big thing back. So if we look closely at this, we have an incoming message, and we have all these like key value pairs. We have stuff on like whatever socket is. We have stuff on client request. But if we sort through all of this, we don't see any actual Pokemon stuff. The reason being, at this point, this information isn't the response body. It's just the response message itself. So remember when we were looking, let's look at a more simple curl. When we were looking at this curl, this was our body, but then we had these two things. We had the request and then the response message. So all we have right now is this like response message. It's formatted a little more complex by the package that we're using. But this doesn't seem to have any like Pokemon information. What we can get from here though is we can get the status code. So this response is object, and if I go .status code and we run our function again, we see that's 200. So the response was successful, but still we have all of this, so much information, but nothing about our Pokemon number 24. The reason for this is that when we open up HTTP request with this HTTPS package, we start what is called a data stream. And so a stream is a collection of data that hasn't all necessarily arrived yet. So if we're thinking about the internet and our roads example, when I send a request to some maybe other like building or server to get something sent back, there are many ways that my request can get there. The network is like a huge interconnected like set of highways, and my message can go one way, can go another way. The second thing is my requests and the responses that are sent back can be of varying sizes. So think of what a nightmare would be if we had to drive from one location to the other, like all with like huge double length like semi trucks. we wouldn't be able to navigate through like smaller roads, and traffic would just be like horrible. Opposed to that, thinking of our current traffic system, if everyone was driving on like say motorcycles, that might make it like much faster. So similarly with our internet and network, our big requests and responses are split up into smaller chunks. And this makes it less strain on like congestion with the network, and it provides each chunk being sent can take like a fastest route that they can find. It gives a lot of benefits to how the network is made. So my request here to this Pokemon API is sent, and then the response that's coming back is sent in chunks, meaning not everything comes in at the same time. To us, it comes in at the same time because computers are insanely fast, but to our program, each of the chunks of the incoming message are being delivered at different times. This is called, again, a stream. So a stream is a collection of data that has not all arrived at the same time. Some of it may have already arrived, none of it may have arrived, all of it may have come, but it comes in at variable times. So with this particular package, there's a way that we can listen for each incoming chunk or thing. If I go https://on, so streams have listeners. They have things or events I can listen for, such as data. So https on data means I'm listening for the event data. I'm listening for when something is coming in. And then, of course, because it's asynchronous, I'm going to use a function to get the chunk that's coming in, the chunk of data. And if I console log this chunk, and then I'm going to add like a new line so it's more obvious how the chunks are coming in. And we run our function. Oh, yes. So I'm not listening on the HTTPS package. I'm actually listening on the response. So here we are setting up the HTTP request and response. And then on the response, which of course has to go where that exists, I'm listening, this new connection that we've set up, this new stream that we've set up, I'm listening for the data coming in. So here we see all of this stuff. I think I saw the word, Poke API. So this is stuff having to do with Pokemon. And if we scroll, we see there's a line break every once in a while. So all of this text from here up to this break, that was one chunk. That came in last in the communication like highway. And then before that, this big chunk came in. And then before that, this one. So they're sending us lots of information, and it would be harder for them to send all of this at once. So it's split into these different chunks. What we could do even, we could go make a new variable called count, set it equal to 0, and we could go count plus plus to see what our current, or I guess the total number of chunks that are coming in. And then we could do console.log of count. The chunk size is, so we got 15 chunks. The chunk size can be determined by you as a requester. You can set it in as a header pair. But if no one sets anything, there's a default size. I don't know in bytes what the default size is, but you can look it up. So we see that our chunks we got 15 things, or 15 chunks of this string from these guys. So it's not really helpful for us to have all of our data in pieces. We want it all together. And to get all of this data together, we can buffer the data. So buffering, like when you're watching a YouTube video and it's waiting for more of the video to come in and adding it on to what you've been watching, we can do a similar process here. So our buffer is nothing, and then as each piece of data comes in, we can go buffer plus equals our new chunk. Oh, chunk. So it starts with nothing, and then we add on the first piece. The second piece comes on, then we add it to that. And by the end of all of these response ons, or these data events, we should have all of the chunks added together. So let's get rid of this. Well, what happens if I do this? If I log this buffer, so we want this to be all of the chunks together at this point. What is this going to output? So yeah, we're hoping it's going to do the entire message. So let's see. I'm going to put some text before it. Here is the message. Okay, so we'll run it. And we get, here's the message, but then we get nothing. And the culprit again is our asynchronous stuff. So in this HTTP GET, we're setting up a stream with our API. We're listening on that stream for data coming in, and this is also asynchronous. So it's waiting, did a new chunk come in? Yes, add it to the thing. Did a new chunk come in? Yes. But because this is asynchronous, JavaScript doesn't wait for this to finish. It kind of like sets a reminder, oh, check back and like do this when a new chunk comes in. And then it continues like down here without waiting, and it runs this right away. So the order of our execution is like this gets set up. It actually would run anything after here. And then once this returns back with a successful connection, it runs this line, 8, 9, and then it runs line 10, and then it skips right down to run line 14. And then once the first chunk comes in, it runs line 11. And then once the second chunk comes in, it runs line 11. But that doesn't help us because we've already console logged our buffer and we got nothing. It also wouldn't help us if we went in here and did a console log of buffer, because it would be logging, the buffer with one chunk, the buffer with 2 chunks, the buffer with 3 chunks, and all the way to the end when we have 15 chunks, it will be logging that. Like we'll have the full data all buffered together, but we wasted all that time logging all of the other combinations of the data as well. So luckily for us, there's another event listener, another stream listener that we can use. So we do the same response.on, and we listen for the event end. And because it's asynchronous, we have this callback function. And this will only be called once all of the chunks have come in. So if at this point we do this console log of buffer, or let's do this one with our nice little message. We'll get rid of this one. This function will only be triggered once all of the data events have occurred, once all the chunks have been read. So chunk 1, 2, 3, we're adding to the buffer all the way to 15. Once 15 is done and the HTTP request cycle knows that it's finished, it will run this end, and we'll have one console log with the entire contents of our buffer. So it's going to be really big again, but if we scroll through this, we can see it's all of our data. I don't know if we'll find the top easily. Oh, there we go. Yeah, we won't find the top, but it's all of our stuff. So that's helpful. But now we need to filter through this huge thing because we got like enough information to write a book on Pokemon. We just want to know the guy's name. So from this big buffer, we're going to need to extract just the name from him. But before we do that, let's kind of clean up how we're returning all of our information. So we just have this one callback here. That's not kind of how we want it. Let's do an if, and we can go response.status code. And we want to check if that isn't successful, so it doesn't equal 200. Then we're going to do the callback. With this like status code that it wasn't good. Otherwise, we can continue listening for all our chunks, and once everything's done, here we're going to do a callback with our buffer. So if our response fails, we're just going to pass on our actions to this function with our response code, like the failed status code. But if we're successful, we're going to pass on the actual information to this response. And we'll log either one. We don't need the console log anymore. That's looking a little nicer. It will run things after the callback. So like we have a callback here, and then all of this stuff will still get run. That's a good point. These two will not get, like we'll set up the listener for data and we'll set up the listener for end, but because the response has failed, they're not going to be meaningful. But exactly, we should not have them do a bunch of stuff we don't need to do if we don't want to. So a cleaner thing would be to have, if our status code is not successful, then we will call back to this function with the unsuccessful status code. Else, we're going to set up all of our buffer and reading all the chunks. And then when that's done, we're going to call back to this function with response. So with this one, we're getting the either or, a more clean approach to it. Either we're calling back this or we're calling back this. Okay. But we want to get something useful from this buffer. So one thing we could try, I have pre-filtered through all of that stuff to make it a little bit easier for us. And we're going to add actually one more thing to make it a little clearer here. Because our callback function here, we're just getting a response. We don't know really whether this response is a successful response or a failed response. So instead of having just one parameter, we could have error and then also response. So if there's an error, we'll set the error. If there isn't, we'll set the response. So then in our callbacks, we have to change them a little bit. This one will be our error. And then we'll set the second parameter, which is our response, to nothing. Because if we're failing, we have an error, but we don't have any data. And the opposite for when we're successful. We don't have an error, but we do have some data. And then in our callback, we can check if, not isFinit, if there's an error, then we are going to console.log the error. Else, we're going to console log the response. Okay, let's just make sure everything's working up to this point. Spelling mistake. So our thing was successful. The HTTP request was successful because we're getting this whole thing logged back. Okay, so what if I want to access a specific value from that JavaScript object? So what is my notation for getting it from this response? So say I know that there's this huge response object that we have. You know, it has like tons and tons of stuff. tons and tons of stuff. But then somewhere along, oh my gosh, somewhere along the way, it has name, and then this is like, how would I access this from if this whole thing is the response? So dot notation, and I do dot. Well, we were looking at dot species before, but you're gonna trust me, and I'm pretty sure dot name is somewhere in that data thing because I've done it before. Okay, so we can try this. We just want to get out of the whole thing the name, and we get undefined. But there's a reason for that, and it's not because dot name doesn't exist, I don't think. So let's try one that we know exists. So the first one that shows up is abilities. So even if we go dot abilities, see if we, let's see if that does anything. So we still get undefined. Yeah, so the comment was that our response here, this is what we've created here is a string. So we've buffered in all of that, the chunks that are coming in, and at this point when we send it back, so we're like, give the buffer to these guys, they get it, and then they're trying to access stuff from it, it's a string. So if we try and do dot notation on a string, we're gonna get undefined. So this is where that whole JSON thing comes in. JSON, our JavaScript object notation, is a way to write a JavaScript object in a string. So this is a string, but we want to, make it an actual object within our code. So there's a method for doing that. We can go JSON dot parse, and what that will do is it'll look in the parameter that we give it. It's like, okay, this is a string. I'm going to check that it's like proper JSON notation, and if everything makes sense, the like brackets are there, the key value pairs are all nice, I'm going to turn it into a JavaScript object. So now if we try and access something from it, we shouldn't get undefined. We should actually be able to get it. So dot abilities, we get an actual thing in JavaScript, an array in JavaScript. But instead of abilities, we want to get name. So again, hopefully this works because we don't want to go looking through all that stuff. There we go. We get the 24th Pokemon is Arbok, apparently, which you would never be able to tell from looking through this. But I think the API is a bit clearer. I don't know. I definitely dug through this and somehow found. Oh yeah, right even here. So this is under something, but all of these ones here are like the first level. So name is a first level key. Name is also a second level key of species for some reason, but we can get name. So is there a way to add it onto this API request to get just the name? Unfortunately, that's all dependent on how these guys set up their API. So maybe they could do something more helpful and have like /name/1 and it would just return the name for us, so we don't need to get all this stuff. But the way they've set it up, they are like, we're just going to dump everything on you if you ask for information on this one Pokemon. So that's kind of API dependent. In general, though, like this seems like so much information, but for our applications, it's like nothing. It's more helpful for us in terms of readability if it was shorter, but our applications aren't going to care that much on whether it's a little bit of text or kind of a lot of text. Okay. So any questions on kind of this flow right now? It is a little convoluted because we have some asynchronous things going on. When we finish it, I'm going to go through a kind of a step-by-step execution flow again, but is there anything particular that's standing out as something that's not clear at this point? Okay, well, we don't have a lot left to do because our function right now is kind of doing the right things. Let's just have it so that it's kind of usable. So again, let's get some input from the user. And we know that's process.argv. And we want the third one, but the second one with 0 indexing. And then our input, I guess we can call it our number. We want to pass it to our function. And then let's have our output text a little nicer. So if the Pokemon doesn't exist, we can maybe write it's in the original like red and blue. There was this Pokemon that could come up called Missing No. Let's look them up. It was like a glitch in the game when they were like trying to index a Pokemon by a number that didn't exist. So that's what's happening here. This number doesn't exist, so we'll just give them Missing No. Otherwise, we want to do something like it's whoever they are. Okay, so save this. So now we can run our application and we can give it a number. What's another number we're curious about which Pokemon it is? 150. Oh. So we get it's Mewtwo. We could even be a little excited about it. Cool. One more will do. Who else? 72. It's our boy Tentacool. All right. So our program's pretty done at this point. I mean, we could handle errors a little nicer possibly, but let's work through the flow. So we're using this package HTTPS. Then we define a function that takes in 2 parameters: a number for the Pokemon number that we'll be looking for, and a callback function to run once we get the data. We take in some arguments from the user, and then we run our function. We pass them the number that the user used, and we pass this callback function that will take the response and print out the string. So once we run this function, it goes in here. It starts this HTTPS GET request to our API's path with the addition of the dynamic number. Once it sets up that request and gets a response back, it will run this function. This function will check and see, well, was the response successful? If it wasn't, it sends an error back to our kind of output function. But if it was successful, we set up this buffer. Our incoming data is coming in chunks, so we're buffering. We're taking each chunk and adding it onto the end of the last one for each incoming data event. So, oh, data's coming in, add a new chunk, add a new chunk. Once all of the data has come in, once all of the chunks have been buffered, our HTTP request response will notify us that it's ended. And then this function is going to be run where we say, OK, we're done. There was no error. And here is all the actual data that we got back. You take it from here, callback. So we go down to our callback. And our callback, in the case that we're looking through right now, didn't have an error. So we go to the else of our if statement, and it's going to console log our bit of message. And we're going to take the whole data thing that we got, and we're going to get .name from it and print it out to the console. If we wanted to, our code right now is kind of flexible in that we're just returning the data. We could make a whole new call of our thing where maybe instead of getting the response.name, we're getting like the abilities or some other key of that huge mess of data that we got back. Point being, we have all this information now that we can parse through, we can use depending on what we want to do. I will be posting this code in the notes. But again, if there's any questions on the flow, we can work through it now. We have some time. Or on APIs or HTTP requests in general, if you guys can think of anything. Here? So the question is, with our GET request here, is it better or cleaner code to, say, define this function outside of it? So we could do, actually we would, it's not going to let me grab. So if I make a function out here, and then instead, I just call or I give reference to my function here. I think that depends. If this function gets big, it's nice to define it somewhere else. When I have functions that are maybe say this one here, I wouldn't necessarily define this one somewhere else if I know that I'm only going to be using this functionality once, and I can just do it kind of inline. The two things I would weigh is, does it get so big that it's kind of unreadable? And the second one, am I going to use this functionality somewhere else? So this thing here, if I wanted to use it in a separate GET request, so I had this GET request, and then maybe I have another GET request to another part of their API, I think they have a whole thing on just the Pokemon fruit. So if I wanted to do that, now I have this repeat usage of this function. Super great to predefine it. If I'm only for sure going to be using it in that one location, then maybe I don't mind if it's inline. The other thing about code is it's kind of like living. I can start with it inline, and then as my code grows, and maybe I find another use for it, I just move it out. Or maybe it gets kind of unreadable, I'll move it out. That is something really good to think about and does lead to cleaner code, but it's something you can kind of decide on a case-by-case basis as you're coding. The two things I would be thinking about, though, is how long it is and whether I'm going to use it again. The other thing, though, also, when we're starting off with callbacks, sometimes declaring it beforehand helps with kind of readability, because I find when we're doing this type of callback, it's easy to think that, oh, this is all just part of the same function. Who's that Pokemon and this function here are the same thing. Whereas when I'm running it like this, it's very apparent that this is one function, and then this is a separate function that gets called at some point. Of course, we'd have to do that. Any other thoughts or questions or comments on our code? The last thing maybe we can do that's kind of a bit of a bonus, but very short, is here we're saying that we should be getting an error back from our thing if the numbers, well, we can test that too. If I go, instead of 72, I do 2,000 or 20,000. I get it's missing, no. But here we're not sending an error, we're just sending a status code. So in JavaScript, it's pretty easy to set up a new error. We can just go new, error, and then you give it kind of like an error message. So we could say invalid response, and then we could add on the so that'd be kind of a nicer way to handle our errors. The error object in JavaScript is just a predefined way of defining errors. So within code, if I use an actual error object as opposed to my just message that I know is an error, there are other handlers and things that we can use around this thing. But I think that's a little bit beyond the scope of this lecture, but you'll see maybe this syntax more and more as you go on. Cool. So that's everything I was going to cover. If you guys think of anything after the fact or while looking through the notes, come find me. I'll be around. But thanks, and yeah, good luck with the HTTP request stuff today. Oh, actually, we'll be seeing each other again. We have breakout today. So if you think of anything before then, let me know, and I can maybe cover it in breakout a bit.